Today let's try to solve another Leetcode problem. 606 construct a string from a binary tree. So we are given a binary tree. We want to get the result of the pre-order traversal of this binary tree, but inside there will be parentheses. And for the parentheses, as we can see, for the left side for this node 2, if there is a right node, so we're gonna keep this open and close parentheses. So for 2 with the open and close parentheses, even there's nothing inside, we're gonna keep it. And for the right side, it's gonna be another 2 with parentheses. And also we can check this situation. For this node 2, for the left side, there's a 4, so we're gonna keep open and close parentheses. But for the right side, we don't need that. Yeah, because this is the representation. So for the right side, if there's no node, so we're gonna not keep open and close parentheses. So this is according to the definition. So omit all the empty parentheses pairs that do not affect the one-to-one mapping relationship between the string and the original binary tree. Yeah. So for example, for this node 3, there's no left and right node. So we're gonna not keep the parentheses. So after 3, there's no parentheses. Yeah. So this is basically a pre-order traversal problem, but the problem becomes a little bit difficult because we need to keep this kind of parentheses inside. Yeah. So basically, we cannot use the pre-order traversal with the numbers directly. If we use with the numbers, we can just get the numbers, but there's no parentheses. So while we are using the pre-order traversal, we should also keep the parentheses in outside the numbers. So how should we do it? We just need to check two situations. So for one situation, if there's no left node, but there's a right node, so we're gonna keep the parentheses. Yeah. And also another situation, there is left node and no right node, so we're gonna omit the parentheses for the right node. Now let's try to write the DFS function. So basically it is a pre-order traversal. So I'm gonna keep a node inside. So if there's no node, so I'm gonna return an empty string. So this is, for example, we have only node 1. So what gonna happen? We just need to keep this number 1 and turn this 1 into a string as the result. So this is why if there's a no node for the left side and the right side, I'm gonna return a none. Yeah. Now I will check the left. So the left will be the DFS, not dot left, and right should be DFS, not dot right. Yeah, but currently for the left side and the right side, we are not sure if this left exists or this right exists. Yeah, if it's not exist, we're gonna return an empty string. Yeah, but if this left side exists, we're gonna, if this left side exists, so we're gonna keep the pressures outside this left. So what we're gonna do, we need to attack. Yeah, we're gonna keep a result as empty string because finally I'm gonna return with a not dot value plus this result. So for example, the first value for this example is 1, so I'm gonna keep the not dot value, it is 1 because this is a pre-order traversal. So so finally in the final DFS, I'm gonna return this not dot value. It should be the not 1. Yeah, because I need to finish the left side. Yeah, it's not pre-order traversal. Left side and the right side, and then I get the node. Yeah. So it is a post-order traversal. I think it's the post-order traversal because I need to keep the finish the left side and then the right side. Yeah, and finally I just put this 1, turn this 1 into a string and put it at the first place. Yeah. So the not dot value should be, I need to turn this not dot value, should turn it into a string. and then plus the result. But the result is dependent on the left and right. So let's check if left and not right. Yeah, so this means if the left node exists, but there's no right node, so what we're gonna do, we just need to put the for, we just need to keep this for with open and close parentheses. Yeah, so the result should equal to the open and close parentheses. Yeah, let me keep the open and close parentheses. And in between, there should left. Yeah, because the left exists. And what is this left? And this left actually is this number 4. Yeah, when it goes to 2, so this left is number 4. So I need to plus open and plus the close parentheses. Just keep it as like this. Yeah, because I need to keep it if the left exists. So yeah, if the right not exist, so I don't need to do anything. Yeah. Now let me just copy the second condition. So the second condition is if right and not left. So this means the right exists and the left not exist. So what I need to do, I need to keep an open and close parentheses first, and then plus the right side. Yeah, so this means the right side exists. So I need to keep the open and close parentheses, and inside I need to keep the right. I need to keep the right side. Yeah, so I need to put the right inside. So basically, this right is a number. So for example, this is right is number 4, and the left side is an empty string, open and close parentheses, and this is the right side. Yeah, and the third condition is if left and right. Yeah, basically the first condition, this result just means if the left side not exist and the right side not exist, so I just need to plus an empty string. So currently, if the left side exists and the right side exists, so what I need to do, I just need to, copy the left side with open and close parentheses plus the right side with open and close parentheses. Yeah, it's a lot of code, but basically we need to understand this kind of post-order traversal. Why it is a post-order? Because we calculated the left side and then the right side, and then we're gonna use the left side and the right side to get the root node. To get the final result. Now let me run it to check if it works. I think I didn't call the DFS function. Now let me just to return the DFS function with root. Let's see what's gonna happen. As you can see, it works. Now let me just submit it to check if it can pass all the testing cases. As you can see, it passed all the testing cases, and the time, it doesn't matter. Because it is still an own solution. We just did a post-order traversal. Let me submit again. Maybe this time it will be much faster. But the principle is just the post-order traversal. We're gonna first finish the left and the right side, and then we're gonna plus this not dot value. With this result. Even the number, it seems a pre-order traversal, but actually, if we want to keep the parentheses, it seems like a post-order traversal, because we finish the left and the right, and then we're gonna use the left and the right to calculate the final result. And finally we get the not dot value. So that's all for today. Thank you for watching. See you next time.